Hello everyone, today we're going to go over your exploring exponents notes. We're going to first define what exponents are, and then we're going to work with their properties. So your objective for today, you should be able to identify the parts of an exponent and how to find its value. Okay, so I will be able to identify the parts of an exponent and find its value. Okay, great. So let's do that. All right, so what is an exponent then? So an exponent is going to be a value expressed as repeated multiplication of the same number. So what does that look like? Well, if I have 2 to the second power, right? So that 2 up here is my exponent, and it tells me how many times I'm going to see this 2, which is my base, appear in the multiplication. So it's really going to be 2 times 2. If I have 2 to the third power, it's going to be 2 times 2 times 2. Right, so I have 3 2's. Okay. Next I have my base. So the base is the number or variable that is to be multiplied by the exponent, is to be evaluated, I should say, by the exponent. So in these examples here, I have 2 to the second power, 2 to the third power. So the 2 here is the base, right? Those 2's there are the base. That is the number that is going to be evaluated by the exponent. Okay, so a factor is any number involved in multiplication or one of the two numbers that make up the value of a number that is being multiplied, right? So if I have the operation 1 times 2, 1 is a factor and 2 is a factor. If I have the operation 2 times 3, 2 is a factor, 3 is a factor. So a factor is any number involved in multiplication. Okay, so those are the first 3 definitions. I'm going to move my page up so that we get to the other 3 parts of the multiplication. All right, so exponential form is the form that we see in front of us in the example on the next page, but we're going to talk about what exponential form is. Exponential form is writing the exponent as a superscript of the base. Okay, so my previous examples all included numbers. So in this example, I'm just going to use a variable. So if I have x as my base and then the number 4 as my exponent, this would be an example of exponential form, where I have my base and then my exponent as a superscript above it. Okay, that is exponential form. So when we're looking at exponential form, the parts of exponential form, there are only two parts. There's a base and there is an exponent, right? The base tells you the number or variable that you are using, and the exponent tells you the number of times that number is going to appear as a factor in the multiplication problem. So I have the number 7 as my base, and it will appear 3 times because my exponent is 3. So I have 7 times 7 times 7, which gives me a value of 343. So that is how I express exponential form and how I evaluate an exponent. I take my base, and my exponent tells me the number of times I'm going to have that base as a factor. And then I just multiply that number of those factors together to get my value. It is just that simple. That's all we really have to worry about when we're talking about exponential form. Okay? All right, so let's practice this idea. Let's identify some parts of some exponents in an exponential form. Okay, so here we have 2 to the 7th power. What is the base here? The base here is going to be, of course, the number 2. What is my exponent? My exponent is the number 7. So when I write out my factors are going to be 2 times 2 times 2 times 2 times 2 times 2 times 2. So I should have 7 2's because that's my exponent. 1, 2, 3, 4, 5, 6, 7. I have 7 2's. So now what is the value of that? Well, I just need to multiply these 2's together. So 2 times 2 gives me 4. 2 times 2 here also gives me 4. 2 times 2 here gives me 4. So now we're going to multiply all of that together. I'm just going to bring this 2 down. So 4 times 4 is going to give me 16, and then 4 times 2 is going to give me 8. So now my final thing is to multiply 16 by 8. And what is that going to give me? It should give me 128. So that is the value of that. It's 128. Okay. Okay. Let's try this next one. We have 3 to the 2nd power. Okay, and that's how we would read that. We would read that as 3 to the 2nd power, or we can also read it as 3 squared. The exponent 2 means squared. Okay, so this is 3 squared or 3 to the 2nd power. So the base is 3, the exponent is 2, right? So when I have the factor, it's just going to be 3 times 3, right? And that is read as, again, which I skipped in the last one, I'm going to read it as 3 squared or 3 to the 2nd power. That's what I read that as. And that value is 3 times 3, which is 9. So here when I read this, I can only read this as 2 to the 2nd power, right? It's just 2 to the 7th power, excuse me. I misspoke before, 2 to the 7th power. So this is 3 squared, right? Or 3 to the 2nd power. Okay, very good. So now we have this. We have an x and we have the exponent of 4. How would I read that? Well, I read what I see. So I have an x, so it's x. And then what's the power? The power is 4. So it's x to the 4th power. Okay, my base is x. My exponent is 4. So it's really x times x times x times x. I have 4 x's. And what is that value? It's just still x to the 4. I can't evaluate it because I don't know the value of x. So I just keep it the way it started. All right. Same thing here. What is my base? My base is 1/2. What is my exponent? My exponent is 3. So when I factor that, it's 1/2 times 1/2 times 1/2. And how do I read this? I read this as 1/2, right? 1/2 to the 3rd power. All right, and what is the value of that? Well, I have to just do 1 times 1 times 1, and then 2 times 2 times 2. 1 times 1 times 1 is just 1. 2 times 2 times 2 is 8. So my value is 1/8. Okay, what is the base here in this example? The base is 50. The exponent is 1. So what is my factor? It's just 50, right? Because it has to appear how many times? Just 1 time, so 50. So how do I read it? It's read as 50 to the 1st power. (50 to the 1st power). And what's the value? The value is just 50. Okay. All right. And here, what is my base? My base is 10. What is my exponent? It is 0. What is the factor? I don't have any, right? I don't write it at all. There's no factors. Because if my exponent tells me how many factors I don't have any, right? So I have 10 to the 0 power. 10 to the 0 power. Okay, and anything to the 0 power has a value of 1. Okay, anything to the 0 power has a value of 1. Anything to the power of 1 is itself, and anything to the 0 power has a value of 1. Okay? So we have identified the parts of an exponent we've identified the parts of exponential form. We're going to keep working here and move on to the next page in our notes. We'll take a look at this hint, and then we're going to do some of this practice. Let me just clear these drawings for us. Okay. Okay, so when we're writing an exponential form, how many times the factor repeats itself is the exponent, right? Just a reminder here. And the number that is repeated is the base. So if I want to switch this to exponential form, I have 2 3's being multiplied together. So then what is my base? My base is 3. How many times do I see that number 3? I see it twice. So that is my exponent. Okay, so this is how I turn something into exponential form. All right, I take the number that's being multiplied, I make that my base, and then how many times I see it being multiplied becomes my exponent. So over here, I have 1/4 times 1/4 times 1/4. So my base is 1/4. How many times do I see that 1/4? I see it 3 times, so my exponent is 3. And I'm just putting those parentheses to be clear that I'm not raising just the 1 to the 3rd power, but the 1/4 to the 3rd power. And that's important when you are writing it by hand, that you indicate with parentheses, and when you're writing a fraction by hand, it's important to put the parentheses and then put the exponent so that we know it's the 1/4 that is being raised to the exponent of 3 and not just the 1. Because if I write it without the parentheses and I just put this exponent here, it's not clear that it's the 1/4. Right? It may just be the 1. So that's why it's important to write it that first way. Okay, let me erase this. Okay, and let's keep moving. All right, here we have 12 times 12 times 12 times 12. The number that I see is 12. How many times do I see it? 4 times. So it's 12 to the 4th power. Okay, and the last one I have x times x times x times x times x. The variable that I see in this case is x and not a number. How many times do I see it? I see it 5 times. My exponent is 5. All right, so again, just to review exponential form, your exponential form is something that looks like this when we have, for instance, the number 3 being raised to the exponent of 6. So again, the base is the number 3, the exponent is the 6, right? That is the exponent, that is the base. We're going to keep moving here and do some practice. We're going to learn some rules, about exponents. And not do practice yet. We're just going to learn some rules about how these exponents work. Okay, so these are the rules of exponents, also known sometimes as the properties of exponents. And we're just saying how these exponents work. Okay, so if I have the same base, right? And there it is being raised to an exponent and then multiplied. So if I have a number, let's just start over. If I have a number, which is represented by the letter A here, if I have a number and it's being raised to a certain exponent, and then it is being multiplied to a number that is the same value as it, and that's raised to another exponent, I can simplify it. Okay, it can be simplified when I do the math. So the A's are the same, they represent the same number. So instead of writing it as a to the m times a to the n, even though that's the way that the rule looks, all right, I want to make sure that I make you understand that my answer is going to be a to the m plus n. So I'm going to replace these a's with numbers just so you can have a better idea. So let's say I have 2 raised to the m power times 2 raised to the n power, okay? This is a multiplication problem. My answer is just going to be 2 to the m plus n. So this is what is known as the product rule. And the product rule says that if I have the same base being raised to 2 different exponents, right, my answer is going to be that same base with the exponents added together. Okay, so when I have the same base being multiplied to each other with different exponents, I just add the exponents together. So in a full example with all numbers, if I have something like 3 to the 3rd power times 3 to the 5th power, my answer is going to be 3 because I always keep the base. If they're the same, I keep the base. And then I add my exponents together. So I just do 3 plus 5. 3 plus 5 would be 8. That is an example of the product rule. Okay. In that same situation, when instead of multiplication, they're being divided, right? So I have a to the m divided by a to the n. I still keep my base, a, but then I subtract my exponents. I subtract n, because it's the denominator, from m, which is my numerator. So I do m minus n. This is known as the quotient rule. So an example with numbers that would look like this. It would be 2 to the m divided by 2 to the n would be 2 to the m minus n. Okay, and then a full example with numbers. Again, we'll use 4 this time. We'll just say 4 to the 4th power divided by 4 to the 2nd power. My answer would be 4 times 4. 4 to the 4 minus 2. What's 4 minus 2? It's just 2. So my answer would be 4 to the 2nd power. That would be an example of the quotient rule. All right. My next important rule says that if I have a to the m, right? So a number raised to some exponent, and then it's being multiplied to another exponent or being raised again to an additional exponent. In this case, I just multiply the exponents together. So my answer is going to be a to the m times n. Right, let me rewrite that in a better way. Not use an x, but use a dot for the multiplication. A times n. All right, so using my 2's again, I'm going to say 2 to the m to the n, which is the same as 2 m to m times n. All right, and then another example over here, if I have 3 to the 3rd power, 3 to the 3rd power multiplied, raised to the 5th power, I just do 3 times 5, but I keep my 3 as the base. 3 times 5 is 15, so it'd be 3 to the 15th. Okay, this is what we call the power of products rule. Okay, and the last one we've seen already, if I have any number or any variable raised to 0, the answer is always going to be 1, and this is the 0 power rule. Or excuse me, the 0 exponent rule. I'm just going to make it 0 exponent. I've heard it both ways. Well, let's just do 0 exponent here. Let's do the 0 exponent. Okay, so anytime we have anything raised to 0, the answer is always going to be 1. So 2 to the 0 is equal 1. 1500 to the 0 power is still just 1. Okay, all right, so we have 4 more rules, I believe. Maybe just 3 more, okay, 3 more rules. Let me clear these drawings and let's do these last 3 rules. Okay. Okay, so this is our negative exponent rule. So if I have any number raised to a negative exponent, I can just rewrite it as 1 over that number raised to a positive exponent. Okay, so replacing this example here with a number but keeping the n. So 2 to the negative n is the same as 1 over 2 to the n. Okay, replacing it all with numbers, I would have 3 to the negative 4 would be rewritten as 1 over 3 to the 4th power. Right, so I just put this exponential form into the denominator of a fraction with 1 on top and make sure that my exponent is now positive. Okay, this also works in the reverse. So if you see something like 1 over 3 to the negative 4, you can just rewrite that as 3 to the 4th. Okay, this is our negative exponent rule. Okay. All right. Rule number 6 tells us that if I have a times b, right, so any two numbers we multiply together and then they're both raised to the same exponent, I can rewrite it as a to the n times b to the n, meaning that I can just apply the exponent to each number separately, because that's really just how multiplication works in general. So it's just an idea of how multiplication works. And so if we rewrite it with just numbers, but keeping our n, we'll have something like 2 times 3 to the n power would still be 2n times 3 to the n. Replacing it again all with numbers, we can say 4 times 7 all to the second power would be the same as 4 to the second power times 7 to the second power. Okay? Similarly, if two numbers are being divided and then raised to an exponent, just like what we saw before, when I had to write the fractions, like indicate that that exponent applies to both the numerator and the denominator, I can rewrite this as a to the n over b to the n. Okay, so replacing it with numbers, if I have 2/3 to the n, it is the same as 2 to the n over 3 to the n. Okay, putting all numbers in there. Let's say I have 3/4 being raised to the second power is the same as 3 squared over 4 squared. Okay. There is a handout on your Schoology page that covers all of these rules so that you have a way to reference them as you do your work. So let's try applying these rules to simplify a few of these problems. So here we have x to the 5th being raised to the 6th power. So what are we going to do here? Well, we're going to use our power of products rule, which means that all we're just going to do is multiply 5 times 6. It's going to give us 30. We're going to keep our base of x and just raise it to the 30th power. Okay, and all we did here was multiply 5 times 6 to get 30. Okay, let's try number 2. For number 2, we need to simplify back here first. We're going to do the same thing we just did for number 1 by multiplying our 3 and our 2 together. So 3 times 2 is going to give us 6, right? And then we have to take that 2 and make sure we also apply it to the 4 in front here. So we need to do 4 to the second power, which is going to give us 16. So we have 16x to the 6th times 3x squared. Okay, and we can just multiply the numbers and multiply the x's together. And we're going to do 16 times 3 is going to give us 48. X to the 12th. Sorry, x to the 8th. I already forgot my rule. So when I'm multiplying the two exponents together, right, with the same base, I just add them. 2 plus 6 is going to give me 8. 2 plus 6, to give me 8, and I have to multiply these two numbers together, 3 times 16 to give me 48. So it's 48x to the 8th. Number 3, we have our power rule because it's the same base. We're going to keep that base. It's definitely going to equal to 6. And then we have to just take our 7 and our 9. And since they're just being multiplied together, we just do 7 plus 9. It's going to give us 16. So it's 6 to the 16th power. Okay. This 4 needs to apply to the -2 and the x. Okay, so we have to do -2 to the 4th power and then x to the 4th power. -2 to the 4th power is going to give us 2 times 2 times 2 times 2. Because we have an even number of negatives, our answer is going to be positive. So 2 times 2 times 2 times 2 is going to give us 16. So our answer is just 16x to the 4th. Our 0 power rule for number 5 tells us that this is just equal to 1, right? And then we have x, so our answer is just x, because 1 times x is just x. Okay, so this -1 is going to apply to both of these. So it's going to be 1 to the -1 over 3 to the -1, right? But we also have our negative exponent rule, which tells us that we can just flip this over and make it positive. So now we have 3 to the 1 over 1 to the 1, which is just 3. Okay, we have 4 more examples to look at. Okay. All right, we're going to use our power rule at the top. That means we're going to keep the base and then add the exponents together. So we have 4 to the 8th power. Okay, and then now we have to apply the quotient rule, which means we just have to keep our base again, which is 4, and subtract the exponents. 8 minus 2 gives me 6. That's my answer. I'm just simplifying, I'm not solving, so I don't have to figure out what 4 to the 6th power is. Okay, and then using my quotient rule, again, here I have to subtract, I have to do 8 minus 9, which is going to give me -1. I keep my base, so it's y. So I have y to the -1. My negative exponent rule means I need to rewrite this as 1 over y to the 1, which is the same as 1 over y. I don't have to write an exponent to the first power. I can erase that. It doesn't need to exist. Okay? And then for number 9, I have 1, 2, 3 x's. It's the same base. So I need to keep my base of x. And then I'm just going to add my exponents together. So it's 3 plus 4 plus 2. 3 plus 4 is 7. 7 plus 2 is 9. So it's x to the 9th power. Okay, here I'm going to use my power of products. I'm going to multiply those two exponents together. I'm going to have x to the 6th. And then I have 5 times 3, which is going to give me x to the 15th. And now I have to apply my quotient rule. So 6 minus 15 is going to give me -9. So I have x to the -9th, which I rewrite as 1 over x to the 9th. Please review these notes as needed to help you with your practices on applying the properties of exponents and simplifying equations with exponents. All right, that is it for me.